1500, what is it, 36. How many do I still have to read? Well, it's still something like 97,000, right? Yeah. So then you would go to the next block and find that, oh, it's actually the end of the file. So then you stop reading.
So you say that if they give me a size of 10,000, but I have only a 1,536 bytes that I can read because my file size is 1,000. Oh, that's. So if I see the end, I'm gonna stop because they ask me more.
Right, because the file stops there. And this is why it's important that you actually return the number of bytes read, right? So at the end of this read, you return, bytes read. Because in case of my last example, that would only be 1536, right? The actual size that we requested was, 10,000 or something. So, but then the caller of this SFS read will see that, the actual size of the file is much smaller than the size. And so in case of this last example, bytes read was 1,536 actually. And so that is what you will return, and not 10,000 or something.
But in the SFS read, there's a static integer SFS read, right? So I can return integer.
So you are returning an integer.
Byte is the integer? No, okay, 2 bytes. Okay, they understand.
Yeah. So the SFS read. Okay, so it's a static function that doesn't really matter anything in your case. It's just static. It doesn't really mean anything right now. But it returns an integer. So SFS read returns an integer. It returns a negative value if you encounter any errors. And then, if you don't encounter any errors, because in this case you didn't encounter any errors, you got a parameter of 10,000, but you've concluded that I can actually only read 3 blocks. So you fill in the buffer with those 3 blocks, and then you return saying I've actually only read 1,536 bytes.
So in the second case, size of 10,000, I don't need to make another if statement, right? Because it's going to understand when it sees the end statement.
Right. So this is why I said that the loop condition is two. It has to have these 2 cases, right? So if you still have bytes to read, which was the case in the first example, when you're reading in a size that is smaller than the size of the file,
yes.
Or when you actually encounter an end block, which is the case for the second example.
You mean with bytes to read is the size?
Yes. Okay. So the size is in the first case 20, and in the second case 10,000. But the bytes to read would be something like, so you would update it at every iteration. You would update it. So the bytes to read would be something like minus equals the bytes that you've read. Right? So at every iteration you would read in bytes read amount, and then you would decrement the bytes read that you still have to read by this amount. Maybe at the beginning you would initialize it, right? So maybe at the beginning bytes to read.
But what
is a size or something, right?
Yes. That's what I don't understand. Bytes to read is a size.
Right. At first, right? And then you would at every iteration of the while loop you would basically decrement it by the number of bytes that you read.
Okay. Can I make a screenshot?
Sure.
Okay. I have bytes to read size that they give me as a parameter. So I'm gonna decrement it every iteration in while loop.
Yep. Yeah. See how this works out, right? So you would decrement this. This is a counter again. Basically, it tells you how many bytes they still have to read.
One last thing. Can I show my screen?
Yeah.
I'm gonna show my screen. I understand what you say. So okay. So in while loop, I'm gonna do that. But in 178, I still don't understand what is this data block offset does, to be honest. Like,
Okay.
it's is it like a filler into the buffer, or what is?
Yeah, so this is an address, basically. Okay, open sfs.h up. The header. This is how the file system is organized, right? If you scroll to the top.
Yes, I can scroll.
Yeah, there you go. So basically, that data offset will be a location in the data area, right? And in the data area are your files stored, basically. So your files, the contents of your files are in the data area. So the data offset is actually the address where your file starts in the data offset. So this is where your where you want to start reading in, because at that location does your file start.
Okay. Yes, I understand.
And how to find this address? Well, it will depend on the first block. So let's remember first block, because every file or every directory, etc., will have this member.first block, which basically gives you an index. It will be the index of the first block.
Yeah.
So you can convert this index into an address in the data offset or data area. Sorry. So if the first block was 4, that means that your file starts at the third block in the data area.
Yeah, I did that with -1.
Yeah. That's all about it, really. And if you want to find the next block of this file, then you have to go to the block table and read in what value is being stored at the third
block table index.
Yeah, third index in the block table, and that will give you the next block, and then you can again convert that next block into an offset in the data area. So if the next block, if you go to the block table and read the third element of the block table, and that will give you a value of 7, then you know that the next block of the file is contained at the 6th block into the data area.
One minute. So you said I can count the bytes that I read.
Yeah.
And in same time, I'm gonna decrement it because of this condition, and I'm gonna increment it to count it for a return.
That will be a separate. So that won't be the bytes to read, but that will be a separate variable.
Yes. So
you cannot decrement and increment the same variable. It wouldn't really make any sense. So that will be a separate variable. Yes. Maybe you would. I don't know if I can go back. Yeah.
But what's the bytes to read? Not data.
The number of bytes that you still need to read in order to reach either the size amounts of bytes, or you stop when you encounter an end block.
No, I understand. So you say that in data part, it gives me a bytes to read.
No. So bytes to read has nothing to do with the data offset. Bytes to read is just something that you keep track inside your SFS read function. The data offset is where the actual contents of the file is stored.
I'm not talking about block table. I'm talking about bytes read. Sorry, bytes read, not bytes read.
Yeah, I understood that. But the bytes read is nothing that or bytes to read. It's just a counter that you keep track inside your SFS read function. So basically, if you read in n bytes, then you would decrement this bytes to read variable by n. Because if you read 100 bytes and the size was 900 initially, then bytes to read is 800. Because if you read 100 bytes, originally the size was 900, then you still need to read in 800 bytes. Right? So
my question was different. I understand what you said. My question is, so what is the term that bytes to read in this context? Like, so I'm looking for it. Size is my bytes to read?
Yeah, so initially, yes. So before you start reading in anything, your bytes to read will be equal to the size. Yeah.
Like if I say bytes to read.
Yeah, so initially it will be size. And then, when you do your disk read, you would want to decrement this bytes to read counter by the number of bytes that you've read in.
This is this is the part I'm asking. So
yeah.
How many
how many bytes have you read in the previous line? You do disk read, buff, etc. How many number of bytes that you've actually read in?
I'm gonna say 512, but you're gonna say no.
Yes, in this case, you've actually read in 512 because so the second parameter in the disk read gives you the number of bytes that you want to read. Yeah? And in this case, your second parameter was SFS block size, which is actually 512. So if you've read in 512, then you would want to decrement bytes to read by that number.
You mean this one, SFS block size?
Yes, in this particular case. But now remember what happens if the size was initially 12 or 20 or something, right? Then you don't want to read in SFS block size. Then you would want to think a little and figure out how many number of bytes that you actually want to read in, right? But still, again, you would keep track of this bytes to read variable, because if the size was 20, then bytes to read initially is also 20. But then the only thing that changes is that you don't read in SFS block size, but you would want to read in 20. And then you decrement bytes to read by 20, and there you go. Bytes to read is now 0. So you exit the while.
Okay.
Because you would add that as a condition.
You mean here?
Yeah. Yeah, exactly. Yeah. So I think just start, think about this a little, and really keeping track of how many bytes have you actually read, how many do you still need to read, and just, I don't know, consult that picture that I've drawn.
Okay, last 30 seconds. I'm not gonna take your time more.
Okay.
You said if it's 20, you should think about it. How I'm gonna find the 20?
Okay, so if the size is 20,
yes,
then the parameter is there. So SFS read has a size parameter that will be equal to 20.
Yes.
Right?
Yes, this is right.
Okay. But then there can be, I guess, two cases, right? Either size is less than a block size, or size is more than a block size, right?
Yes.
So if you have if the size is less than a block size, then you can read in only size, right? So size is 20, then you can read in just size amount. Or if the size is more than a block size, which is, I don't know, 2000 bytes, then you can read in a block size.
Oh, so I'm gonna make it two conditions. So I'm gonna check the size. If its size is bigger than 512, I'm gonna decrement SFS block size. If it's not bigger than 512, I'm gonna decrement bytes to read from bytes to read.
Well, yeah, or the size. So basically the size that you've read in, actually. So if it's less than a block size, if it's something like 20 bytes, then bytes to read is initially 20 bytes, and then you would only read in 20 bytes, then decrement bytes to read by 20, and then bytes to read will be equal to 0, so you exit the loop.
I think I'm gonna make a if condition here, I guess. Okay.
Okay, just try that. Okay?
Yep, thank you.
Yeah, good luck.
Thanks.
Bye-bye.
Bye-bye.